Significant figures.
Hi students, today we are going to discuss our new topic, significant figures. So I know you guys learned something about significant figures in class 8 max. So we are going to look deep or detailed into this concept. So when we write a significant figures, there are some reliable digits and there are some uncertain digits. Reliable digits and uncertain digits. So when we talk about the reliable digits, these digits have some fixed value that is not going to change. And about the uncertain value, it may be changed when we take the correct value. For example, when we talk about the gravitational constant G, what is its value? How many of you remember that value?
It is 6.67 into 10 raised to 11 Newton meter square per kilogram square, sir.
Yes, it is correct. So 6.6 into 10 raised to 11 Newton meter square per kilogram square. So now we consider the first part 6.67 only. In the part 6.67, there are some reliable part or reliable digits. In that the 6 before the decimal and the 6 after the decimal, they are reliable digits. And the last one is 7, that is not reliable because when we find the actual value, it is not 7, it may be some other value. So for convenience we may round it off, or we may just remove the remaining digits for our convenience. So the last one is not reliable, that is they are uncertain. So a significant figure consists of reliable digits and last uncertain digit. Okay. For writing significant figures, there are mainly 6 rules. Okay, so we cannot simply write the significant figures. We have to follow some rules. So let us start with the rules. Before that, I just have some introduction. A choice of change of different units does not change the number of significant digits or figures in a measurement. That is the first thing that we have to take care when we have to write. This is the main reason why we are using significant figures, because if you are changing the unit from centimeter to meter or to kilometer, the value doesn't change. Why this is not change? Because the significant figures is taken such a way that, and the coming next 6 rules will discuss how this is going to implement. For example, if you take the length as 2.308 centimeter and there are 4 significant figures. Here the significant figures are 2, 3, 0 and 8. These are the 4 significant figures here. And when we convert the centimeter to meter, it becomes 0.02308. There also the significant figures are 4. Or if we convert to millimeter, it becomes 23.08 millimeter. Or when we change it to micrometer, what happened? It became 23080 micrometer. So whenever we change the unit, the significance are only 4, it remains 4. And how we can calculate the significant figures, that we are going to discuss in the coming sessions. Okay, so here you can see the rules to finding the writing a significant figures. So the rules, first one is, are you able to see here on the side you can see that one. All non-zero digits are significant. So in the above example, 2, 3, 0 and 8 are significant. The 0 is there, but I will discuss. All zeros between 2 non-zero digits are significant. Now you understand why I say 0 is significant. Okay, if the number is less than 1, the zeros on the right of the decimal point but to the left of the first non-digit are not significant. That is, if you take the example 0.002308, the zeros before 2, there are 3 zeros, they are not significant. Okay, and next one, the terminal or trailing zeros in a number without a decimal point are not significant. If we write 1000, 1 is only significant. The last zeros are not significant. But there are some cases. But when we discuss about the trailing zeros in a number with the decimal point are significant. For example, 3.500 or 0.06900 have 4 significant figures. In the first case, 3, 5, 0, 0 are significant, and in the second case, the 0 preceding to 6 is not significant, but the zeros after 9 are significant. Okay, so these are the basic rules we have to listen. We have to take care when we write significant figures, and this is the first rule that we completed and some rules, and we have to discuss 5 more rules, and second one next rule will clear the doubt that arises in the preceding zeros or trailing zeros. There can be some confusion regarding the trailing zeros. Suppose the length is reported as 4.700 meter. So when we convert to other units, it may be different. For example, if we converting to centimeter, it is 470.0 centimeter. If it is millimeter, 4700 millimeter, and for kilometer, 0.004700 kilometer. Okay, so last number is trailing, and it is not in decimal. As per the above rule, we have to remove that. But here we cannot remove because this is used for the precision. Okay, so when we use that zeros, we got the clear idea when we convert to the different units. So for this, there is another rule that is called, we are changing it to the power. We are converting it to the power of 10. So in this notation, every number is expressed as a into 10 raised to b, 10 to the power b. Okay, we can say like that. Okay, and if it is zeros are on the front or it is before the numbers, and after the decimal, we used to take the negative power. And if the zeros are after the number, after the natural number, okay, and there is no decimal, we use positive power. So these are the notations that we are going to use. Could you tell me one example of such a number?
Yes, sir. The previous example, value of G 6.67 into 10 raised to 11.
Yes, you are correct. The value of capital G is an example of this rule. Okay, so I am giving one more question. It is the speed of light. So could anyone tell me the speed of light?
Sir, it is 3 into 10 raised to 8 meter per second.
Yes, you are right. The value of speed of light is 3 into 10 raised to 8 meter per second. You're correct. So when we check like this, we already learned many examples like this. So you have to write some examples. That is your today's work. You have to write the examples of the values of different constants that we learned in previous classes in your notebook. That is your today's work. Now we are coming to the fourth rule. The scientific notation is ideal for reporting measurement, but if this is not adopted, we use the rules adopted in the preceding example. For a number greater than 1 without any decimal, the trailing zeros are not significant. For example, if you take a number greater than 1, 2, 5, 6, okay, without any decimal, the trailing zeros are not significant. And second one, for a number with a decimal, the trailing zeros are significant, because if we take 2.000 after the decimal, it is significant. So 2.5000. Okay, that means the 3 zeros after that 5 are significant. Next rule is the zero conventionally put on the left of a decimal for a number less than 1. For example, 0.1250. So this 0 is left of the decimal. So that 0 is not significant. But this 0 on the last or on the right, 1250, that last 0 is significant. That's the rule number 5. And the rule number 6. The multiplying or dividing factors which are neither rounded numbers nor numbers representing measured values are exact and have infinite number of significant digits. For example, in r is equal to d by 2 or s is equal to 2 pi r, the factor 2 is an exact number and it can be written as 2.0, 2.00 or 2.000. Okay.